Today we're starting our first day of review. We're using that new review booklet. A couple of things we want to remember with our do now today that I chose for us. We want to remember that the absolute value of any number is positive because it's that number's distance away from zero on the number line, and distance is positive. And we want to make sure we are following PEMDAS as we go through and we simplify our expressions. So our absolute value bars also work as a grouping symbol. So we are going to work inside those absolute value bars and then do the absolute value bars themselves, similar to multiplication. So here we're going to go inside. 6 times 2 is 12. So we got absolute value of 10 minus the absolute value of negative 5 plus 12. Now, some people are tempted to combine that double sign here. You cannot. You cannot combine a double sign through an absolute value bar. You cannot distribute over an absolute value bar. You must perform the operation of that absolute value bar first. So we take absolute value of 10 is 10 minus absolute value of negative 5 is positive 5. So it becomes minus 5 plus absolute value of 12 is 12. So now remember, we can kind of do that team game here. This is a simple example to do a team game, but it's good discussion for our review, right? Negatives, we have 5. Positives, we have 10 and 2. We got negatives have 5. Positives have 22. So that means positives win by 17. So again, as we go to our second expression here, I'm going to work inside those absolute values first because they work as a grouping symbol there. So we've got 9 squared minus absolute value of 10 plus 5 times 3 squared. Now we're going to do our exponents. 9 squared is 81 minus our absolute value of 10 plus 5. 3 squared is 9. Still have our multiplication. Now at this point we can do our absolute value, we can also do our multiplication. So we have 81 minus absolute value of 10 is 10 plus 45. So if we do our team game again, right? Negatives have 10, positives 81 and 45, which gives us 126. Positives win by 116. Here we are on page 2 in our year-end review booklet. We're going to go over a lot of topics today: properties, number sets, operations with fractions and integers. It's a quick review. It's something we should remember from earlier in the year. For more detailed review, you might want to go back to that skills review booklet from the beginning of the year. That's where we have all our definitions of our all our properties, our number sets, and things like that. Okay? So here we are, we've got all our properties, so we're just gonna match them to what they are. So first one here on the top left, 8 plus 9 plus 1 equals 8 plus 1 plus 9. What I'm seeing here is a change in our grouping. We also see a change in order, but I'm gonna say that this one, I think of this one as the associative property of addition. We also see sort of that secondary property of our commutative property where we see a change in order. So really we have two going there. On 8 times 9 times 9 times 1 times 8 times 1 times 9, our grouping stayed the same. There's still the 9 and the 1 in the parentheses, so it's not associative property. We don't have a change in grouping. Instead, we just have a change in the order of our numbers. So this one would be our commutative property. And there's no need to write property of addition. That's fine there. Negative 8 times 1 equals negative 8. That's what we see here. We're multiplying. We're getting a same number. That's our multiplicative identity. Multiplying by 1, maintaining that same identity, multiplicative identity. Here, negative a times negative 1 over a equals 1. That's where we see our multiplicative inverse. Right? And that number itself, right, is the inverse. A lot of times we use the word reciprocal to refer to that. Down here on the bottom left, we have 2/3 times 2/3 minus 2/3 equals 0. What I want to think about is how this simplifies to 0, and what we have happening here is really 2/3 times 0 equals 0. So hidden within that is really our 0 product property. Negative 2/3 plus 2/3 equals 0. That's our additive inverse. Okay. Negative 2/3 plus 0 equals negative 2/3. That'll be our additive identity. Okay. Now here we've got a good one. 2a times a plus 1 equals 2a squared plus 2a, right? We think about that. How would I get that? I would be distributing. That's our distributive property. Right. So now down here on number 2, we're going to identify which number sets each number or value belongs to, and we're going to circle all that apply. Now, a little review here. Real numbers, that's really any number you can think of, and it includes all the sets below it. Rational numbers, those are any number that can be written as a fraction. So that'll include decimals that terminate, stop, decimals that repeat, have a pattern, are integers, all those numbers. Irrational numbers, those are numbers that cannot be written as a fraction. So pi, square root of 2. Now remember, you can either be rational or irrational, never both. Okay? Our integers, those are our positive and negative whole numbers in 0. Whole numbers, that'll be 0, 1, 2, 3, 4, 5, 6, and so on. And then our counting, or our natural numbers, 1, 2, 3, 4, 5, 6, and so on. The only time we have decimals or fractions is when we are a rational number. Okay, so the number -5, I like to kind of start from the bottom. No, it's not counting. No, it's not whole. Yes, it's an integer. And yes, it's rational. We can write it as a fraction. And it's a real number. 0, nope. Yep, it's whole. Yes, it's an integer. Yes, it's rational. And yes, it's real. 2/3, nope, 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 nope. It's rational and it's real. 7.2671 goes on forever. That's showing us no pattern. So this one's just going to be irrational and real. Now 7.2671, it stops, it terminates. That can be written as a fraction. So that one's going to be rational and it's going to be real. -5.3 repeating, that has a pattern. That can be written as a fraction, -5 1/3. So that's going to be rational and real. 12 pi, pi is irrational. So rational, irrational, and real. Square root of 100, we know that simplifies to 10, right? That 100 is a perfect square. Square roots of perfect squares are rational. So it's rational, it's real. When we simplify it, we get 10. So it's an integer, it's a whole number, and it's a natural. Square root of 200, we don't know what that simplifies to. It simplifies to some number that goes on forever and ever and ever with no pattern. So that makes it real and irrational, right? Square roots of non-perfect squares are irrational. On page 3, we're going to work with simplifying our expressions. Our first one here on the top left, we're going to be combining double signs and then using the team game. So we want to remember same sign, sum, different sign, difference. So we find it, different sign, difference. Same sign, sum, and not there, that's multiplication. Now we're going to rewrite 34 minus 45 plus 23 minus 12 minus 7 times -8. Now order of operations, we have to do that multiplication first. 34 minus 45 plus 23 minus 12. -7 times -8 is positive 56. So now we can go over, use our team game to organize everything. So negatives are 45 and 12, positives 34, 23, and 56. So we'll add all of those up, which gives us 113 for the positives and 57 for the negatives. I can see the positives are going to win, so find the difference, right? If you can't see the difference right away, go for our subtraction, right? Line it up there, right? So positives win by 56. And there's our answer. Okay, now in our next expression, we're really working on following PEMDAS there. So as I go, we're going to go into our grouping symbols. So we'll go into the parentheses and the absolute values. 3 to the third minus 3 times, let's see here, 20 divided by 10 is 2, right? Multiplication, when we've got that, we work from left to right, times 2 squared plus negative 3 plus 2 is negative 1. Okay, now we're still working inside those parentheses. 3 to the third minus 3 times 4 squared plus the absolute value of negative 1. Now we'll go to our exponents. 3 to the third is 27 minus 3 times 4 squared is 16 plus the absolute value of negative 1. So let's do our multiplication. We'll also simplify our absolute value. 3 times 16, negative 3 times 16 will be negative 48. Absolute value of negative 1 is 1. So if we think of our team game, negatives are 48, positives 27 and 1, so that's 28 and 48. Negatives win by 20. Down here on the bottom left, we're finally getting into some fractions and decimals here. One thing we want to do is we either want to change everything to decimals or everything to fractions. I'm going to suggest we change everything to fractions. So negative 2.25, I have to realize 2.25 benchmark fraction is 1/4. So that's negative 2 and 1/4 minus 2/5 times 4 and 1/6 minus 1/2. I'm going to take all these fractions and convert them to improper, right? Remember, we do 4 times 2 is 8, plus 1 is 9. Now we put that negative back on there. Minus 2/5 times, let's see, 6 times 4 is 24, plus 1 is 25, 25/6, minus 1/2. I'm not going to distribute here. It's PEMDAS, order of operations, right? Do the subtraction in there. To do that subtraction, I need a common denominator. Common denominator is going to be 6, so I go times 3 times 3. Okay, now I can rewrite what's in the parentheses with that big single common denominator of 6. So that's going to be 25 minus 3, making this negative 9/4 minus 2/5 times 22/6. Now we're going to multiply. I might notice I can reduce that fraction, or I'm just going to kind of cross cancel here anyway. So common factor is 2. 2 goes into negative 2, negative 1 times. 2 goes into 6 3 times. So we multiply straight across, which gives us negative 9/4 minus 22/15. Now to do that subtraction, we're going to need a common denominator. Common denominator between 4 and 15 is going to be 60. So we're going to do times 4 times 4 times 15 times 15. I'm just going to kind of slide that work over here. Okay, let's see. So negative 9 times 15 is going to be negative 135. 22 times 4, negative 88. Remember, they're both negatives, so it's like we're adding. Negative 135 minus 88 is going to be negative 223/15. And I want to make sure that's fully reduced. The only possible common factor would be 3, so I checked 3. 2 plus 2 is 4, plus 3 is 7. That's not divisible by 3, so we're fully simplified. Oopsies. 15 times 4, 60. Common denominator is 60, not 15. That answer is negative 223/60. Up here, we're going to do essentially the same thing, change everything to fractions and go from there. 0.2 2/10, 1/5. And let's bring everything into improper too. 3 times 3 is 3, plus 1 is 10, so that'll be minus 10/3 divided by, let's see, that'll be 15 over 2 plus 7/15. Order of operations, we've got to do this division first. We want to remember, keep, change, flip. Okay, now that we're multiplying, we can look for cross-canceling, and I see it here. Common factor is 5. 5 goes into -10, -2 times. 5 goes into 15 3 times. Now you multiply straight across. That's going to be 1/5 minus 4 over 9 plus 7/15. So now we've got to get the common denominator, which I'm thinking the common denominator is probably going to be 90. Yeah, it's going to be 90. So let's see, single common denominator of 90. So 5 times 18 will give us 90. 9 times 10 will give us 90. And then, let's see, 15 times 6 will give us 90. So in our numerator, that's going to be 18 minus 40 plus 42. And remember, we can use team game for our numerator there, right? Negatives have 40, positives 18 and 42, which gives them 60 for the positives, 40 for the negatives. So positives win by 20, 20 over 90. And you can see that common factor of 10, so it reduces to 2/9. On number 4, we're going to evaluate for when a equals -2, b equals 3, and c equals -2/3. Remember, when we evaluate, we're going to substitute in using parentheses. So I write everything that's there and then substitute in for our variable. So we have a negative. Now I substitute in for a, which is -2, b to the third, and then c -2/3 squared. Okay, now remember, order of operations, we're going to do our exponents first. So it's going to be -2. 3 to the third is 27. Now that -2/3 squared, if I go off to the side and think about what's going on there, -2/3 squared tells me the base is -2/3. So -2/3 times -2/3 gives us +4/9. So that's going to be times +4/9. Right, negative times -2 is +2 times 27 times 4/9. 2 times 27 is 54. So that's going to be 54 over 1 times 4 over 9. And there's a common factor there of 9. 9 goes into 9 once. 9 goes into 54 6 times. So 6 times 4 is 24. 24 over 1, 24. Ooh, that was nice. Okay. All right, -a to the 4th plus 6c squared. So we're going to have negative, and then in parentheses, -2 to the 4th plus 6 times -2/3 squared. Okay. Do not combine that double sign. Remember, think of that as a -1 times the -2 to the 4th. So as I go off to the side and I think about my -2 to the 4th, that's -2 times -2 times -2 times -2. That's going to give us a +16, right? -2 times -2 is +4 times -2, -8 times -2, +16. Okay, so that means we're going to have negative and then 16 plus 6 times, and then that -2/3 squared, right? -2/3 times -2/3 is going to be +4/9. So 6 times +4/9. So -16 plus 6 over 1 times 4 over 9. Common factor is 3. 3 goes into 6 2 times. 3 goes into 9 3 times. So that's going to be -16 over 1 plus 8 over 3. To do that, we need a common denominator of 3 times 3 times 3. That will give us -48 plus 8 over 3. So -40/3 as our answer. Today's math jokes for mathy folks, not super mathy, but still a favorite nonetheless. How do you make time fly? Throw the clock out the window. Have a great day.